Hello learners, good evening. Today we are going to be learning about geometric progression. In our last lesson we learned about arithmetic sequence and series, and we learned on how to determine the nth term. We also learned on how to determine the sum of the terms of an arithmetic series and sequence. So today we are going to learn about geometric progression. And a geometric progression is also another sequence. It is also a sequence. It is a sequence. It is a sequence. So if we have an example, for example, if our example 1 is in this format, we have 4, we have 8, we have 16, we have 32, and that is how our sequence proceeds. So if you check clearly, 4 and 8, if you take 8 and subtract 4, you are going to get a difference of 4. If you take 16 divide by 8, you will get a difference of 8. So talking of subtraction or the difference, this cannot be an arithmetic progression. So this one, it cannot be an arithmetic progression. It cannot be an arithmetic progression. So in this case, you can note that the preceding or the number that is preceding the first one is a multiple of 2. So 8 divided by 4 is equal to 16 divided by 8 is equal to 32 divided by 16, which is equal to 2. And this 2 is what we call a common ratio. A common ratio. So in this scenario, our common ratio is equal to 2. So a geometric sequence has got what we call the first term. The first term, which is represented by A. Then we have a common ratio, which is represented by R. So finding the nth term. So for us to find the nth term of a GP, the formula is nth term is equal to A, which represents the first term, R to power n minus 1. AR to power n minus 1, where A represents the first term, R represents the common ratio, and n represents the number of terms. The number of terms. So that means that if we have an example 1, find the 10th term of 2, 4, 8, comma, we are supposed to find the nth term. That is what we are supposed to determine. How are we going to go about it? We are going to first determine our common ratio. And our common ratio in this case will be 4 divided by 2. So 4 divided by 2 is 2. And we said we also confirm with 8 divided by 4, which is also equivalent to 2. So our R is 2 and our A is 2. Therefore, our nth term, which is Tn, should be equal to AR n to power n minus 1, which will be equivalent to, we want to get T10. So our 10th term will be equal to AR, then n is 10 minus 1, 10 minus 1 which will give us our T10 is equals to AL to power 9. AL to power 9. So for us to get that one, we can now bring it this side. Our 10th term is equals to AL to power 9. Our A is equal to 2 and our R is equal to 2. Therefore, our 10th term will be equal to A is 2. We can multiply here in brackets. Our R is 2 to power 9. And by the use of our calculator, we are going to take 2 to power 9. 2 raised to power 9 will be equal to 512. Then 512 multiplied by 2, these two here, we will get 1024. So the 10th term will be equal to 1024 or 1024. And that is how we determine the nth term. That is how we determine the nth term. That is how we determine the nth term. For example, we can have another question here. Example 2. Find the 18th term for the following series. For the following series. The series is 3 plus 6 plus 9, not plus 9, 3 plus 6 plus 12 plus, we are supposed to find the nth term. We are supposed to find the 18th term. We are supposed to determine the 18th term. So we have just said that our A is 3. Our R is 6 divided by 3 is 3. And 12 divided by 6 is 3. 12 divided by 6 is 2. 6 divided by 3 is 2. 12 divided by 6 is 2. Therefore, our 18th term, Tn, is equals to A R n minus 1. So T18 will be equal to AR 18 minus 1. 18 minus 1 is equal to 17. So T18 will be equal to AR to power 17. And our T18 will be equal to A is 3. R is 2 to power 17. So 2 to power 17 is 131,072 multiplied by 3. It will be equal to 393,216. That is going to be our answer. So let us now proceed to do some examples from the KCSE examination.